For example 1 in section 5.5, we're going to look at linear relations and functions. So our graph shows the cost of booking rooms for a night at a local hotel. So our dependent variable here is our total cost per night. Our independent variable is number of rooms. And if I look at the points that I've plotted, one room, $75, two rooms, $150, and so on. So the question is, after I plot those points, should the points on the graph be connected or not? Well, that comes down to, is it possible to call up the hotel and say I would like to book 1.5 rooms? If that makes sense, the data is continuous. In this case, no. You either book one hotel room or two hotel rooms. So the data is discrete, and for that reason, we do not connect our points. We're going to spend a bit of time now talking about domains and ranges. So our domain is a set of independent or x values. So in our graph, the independent variable was the number of rooms booked. And remember, that can have no fractions and no decimals, which means there are no parts of a room that we're able to book. So we're only looking at the x-axis. So if we could only drop these points down to the x-axis where values would be considered, I would have one room as a possibility, two rooms, three rooms, four rooms. So really, my graph of just what values on the x-axis would make sense would be graphed like this. It would be a sequence of dots, not connected because you can't book half of a room.